A gear switch is a type of electrical switch installed in an electrical panel to control multiple circuits. It does not automatically provide ground fault circuit interrupter or GFCI protection to outlets connected to those circuits. GFCI receptacles are required in specific locations such as bathrooms, kitchens, and wet or damp areas to prevent electrical shocks. To ensure all outlets meet GFCI requirements, install GFCI receptacles at each outlet or install GFCI circuit breakers in the electrical panel to protect the entire circuit. In healthcare facilities, the National Electrical Code, or NEC, specifies where GFCI protection is required. Article 517 covers healthcare facilities and outlines the requirements for electrical installations in these locations. GFCI protection is intended to protect people from electrical shock hazards. A ground fault occurs when there is an unintended electrical path between a source of current and ground. This can happen if someone touches a live wire or if there is damage to the wiring. GFCI devices detect these ground faults and quickly shut off the power to prevent injury. Standard circuit breakers are designed to protect against overloads and short circuits, not ground faults. Overloads occur when too much current flows through a circuit, which can cause the wires to overheat and potentially start a fire. Short circuits occur when there is a direct, low-resistance connection between 2 points in a circuit, such as when a live wire touches a neutral wire. This causes a large surge of current that can damage equipment and cause a fire. GFCI receptacles and circuit breakers work by monitoring the current flowing into and out of a circuit. If there is a difference of more than a few milliamperes, it indicates a ground fault and the device trips, cutting off the power. GFCI receptacles have a test and reset button to verify they are working correctly. It is recommended to test GFCI receptacles monthly to ensure they are functioning properly. GFCI circuit breakers have a similar test button and provide protection for the entire circuit. When renovating spaces in healthcare facilities, it's essential to consult the NEC and local electrical codes to ensure compliance. This includes identifying areas where GFCI protection is required and installing the appropriate devices. Using a gear switch does not eliminate the need for GFCI protection in these designated areas. Electrical inspections are crucial to verify that the electrical work meets safety standards and code requirements. Inspectors will check for proper wiring, grounding, and GFCI protection. In addition to GFCI protection, other electrical safety measures are important in healthcare facilities. These include proper grounding of equipment, using isolated power systems in critical care areas, and regularly inspecting and maintaining electrical equipment. Isolated power systems are used to reduce the risk of electrical shock to patients in critical care areas. These systems isolate the electrical supply from ground so that a single fault to ground will not cause a shock hazard. Regular inspection and maintenance of electrical equipment can help identify and correct potential hazards before they cause problems. This includes checking for frayed wires, loose connections, and damaged equipment. Healthcare facilities should have a comprehensive electrical safety program that includes training for staff on electrical safety procedures. This training should cover topics such as recognizing electrical hazards, using electrical equipment safely, and reporting electrical problems. The type of wiring used in healthcare facilities is also important for safety. Wiring should be appropriate for the environment and should be installed according to code requirements. For example, in wet or damp areas, wiring should be moisture resistant. The NEC provides specific requirements for wiring methods in healthcare facilities. These requirements are designed to ensure that the wiring is safe and reliable. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shock hazards. All electrical equipment should be properly grounded. Grounding systems should be inspected regularly to ensure they are functioning properly. Surge protection is also important in healthcare facilities to protect sensitive electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protective devices, or SPDs, can help to protect equipment from these surges. The NEC requires surge protection in certain healthcare facilities. The installation of electrical equipment in healthcare facilities should be performed by qualified electricians who are familiar with the NEC and local electrical codes. Electrical work should be inspected by a qualified electrical inspector to ensure it meets safety standards. Proper labeling of electrical panels and circuits is important for safety and maintenance. Labels should clearly identify the circuits and the areas they serve. This can help prevent accidental disconnection of critical equipment. Emergency power systems are essential in healthcare facilities to provide power to critical equipment during power outages. These systems should be regularly tested and maintained to ensure they are functioning properly. The NEC provides requirements for emergency power systems in healthcare facilities. Battery backup systems can also be used to provide power to critical equipment during short power outages. These systems can help to prevent interruptions in patient care. Regular testing of GFCI devices is crucial to ensure they are working correctly. The test button on GFCI receptacles and circuit breakers should be pressed monthly to verify that the device trips and cuts off the power. If a GFCI device does not trip when the test button is pressed, it should be replaced immediately. The NEC requires that GFCI devices be tested regularly. Healthcare facilities should have a written electrical safety plan that outlines procedures for electrical safety, inspection, and maintenance. This plan should be reviewed and updated regularly. The electrical safety plan should be readily available to all staff members. Training on the electrical safety plan should be provided to all staff members. All electrical incidents should be reported and investigated to identify the cause and prevent future incidents. The investigation should include a review of the electrical system, equipment, and procedures. Corrective actions should be taken to address any identified problems. Electrical safety audits should be conducted regularly to assess the effectiveness of the electrical safety program. The audit should include a review of the electrical system, equipment, procedures, and training. Recommendations for improvement should be implemented. The use of extension cords should be minimized in healthcare facilities. Extension cords can be a safety hazard if they are not used properly. If extension cords must be used, they should be heavy duty and should be used only temporarily. Extension cords should not be run under carpets or across walkways. Power strips should be used with caution in healthcare facilities. Power strips can be overloaded if too many devices are plugged into them. Power strips should be equipped with surge protection. Power strips should not be daisy-chained together. Electrical equipment should be inspected regularly for damage. Damaged equipment should be removed from service and repaired or replaced. Electrical equipment should be cleaned regularly to prevent the buildup of dust and debris. Dust and debris can cause electrical equipment to overheat and fail. Electrical equipment should be used in accordance with the manufacturer's instructions. The manufacturer's instructions provide important safety information. Electrical equipment should be stored in a dry, safe place. Electrical equipment should be protected from damage during storage. The use of portable generators should be carefully controlled in healthcare facilities. Portable generators can be a source of carbon monoxide poisoning. Portable generators should be operated outdoors in a well-ventilated area. Portable generators should be equipped with carbon monoxide detectors. Healthcare facilities should have a policy for the use of portable generators. The policy should address safety, installation, and maintenance. The policy should be reviewed and updated regularly. The electrical system in a healthcare facility should be designed to meet the needs of the facility. The electrical system should be reliable and safe. The electrical system should be inspected and maintained regularly. The electrical system should be upgraded as needed to meet the changing needs of the facility. The electrical system should be designed to minimize the risk of electrical shock. The electrical system should be designed to prevent electrical fires. The electrical system should be designed to protect sensitive electronic equipment from damage caused by voltage surges. The electrical system should be designed to provide emergency power to critical equipment during power outages. The electrical system should be designed to be energy efficient. The electrical system should be designed to be environmentally friendly. The electrical system should be designed to be easy to maintain. The electrical system should be designed to be cost-effective. The electrical system should be designed to meet all applicable codes and standards. The electrical system should be designed to meet the specific needs of the healthcare facility. The electrical system should be designed to be flexible and adaptable to future changes. In summary, gear switches do not replace the need for GFCI protection. GFCI receptacles or circuit breakers must be installed in accordance with the NEC and local electrical codes to ensure electrical safety in healthcare facilities and other locations where GFCI protection is required. Regular inspection, testing, and maintenance of electrical equipment and systems are essential to prevent electrical hazards and ensure patient and staff safety. Compliance with electrical codes and standards is crucial for creating a safe and reliable electrical environment.